If you're a woodworker wanting to learn 3D printing, I'm going to help you cheat by giving you all the answers to the test in a single video without any of the fluff. 3 years ago, I knew nothing about 3D printing, and I wasted thousands of dollars on the wrong printers and the wrong filament. Today, I have 16 printers in my print farm, and my real business is printing woodworking accessories for people like you, so I've learned a lot over the years. Everything I share with you comes from my hands-on experience of printing this stuff every day for the last 3 years. In this video, you'll learn which printers are worth your money and which to avoid, the filament types that matter for woodworking, simple software settings for pro-level prints, how to get 3D files without needing to be a designer, and most importantly, what to do when things go wrong when you're ready to smash it with a sledgehammer. Now, this isn't a typical YouTube video for me. This is more like a free masterclass for woodworkers who want to learn 3D printing. I'm making this because I wasted so much time going down the YouTube rabbit hole, and there's a lot of bad videos out there, and I want to save you from that headache. And just to be clear, this video is not sponsored by any 3D printing company, but it is sponsored by Shopify. There are two common types of 3D printing. SLA printing uses light to harden liquid resin into 3D printed objects by exposing a vat of resin to a light source. Sounds complicated. I don't have any experience with SLA. The printers and process needed are expensive, messy, it involves chemicals, cleaning, and curing, and at that point, I'm out. So we're going to focus on FDM printing, which builds up objects by layering very thin layers of gooey plastic like a hot glue gun. Imagine putting a hot glue gun controlled by a computer on a CNC XY gantry, and instead of lowering the router bit and removing material, it's stacking material by raising it up. That's basically an FDM 3D printer. This video is going to focus on the hot glue gun variety of printing because that's the most common and affordable option to us woodworkers. This is a spool of filament, also known as $20 to $50 of your hard-earned cash. It comes in a lot of different types, colors, qualities, and I've got a chapter coming up where I dive into all things filament. It's pretty cool. You'll start by saying, I only need 1 or 2 rolls, but we all know you're gonna fall into the same trap as every other 3D printing nerd that hoards hundreds of spools paid for by their kid's college fund. The filament is fed through an extruder, passes through a tube to the hot end where it is heated to over 200 degrees Celsius minimum. The melted plastic is then extruded through a nozzle onto a specialized bed where it adheres and then begins to cool. And it does that over and over again until you have a finished part. Now this is important, and I made this mistake early on. Not all hot ends are created equal. Cheaper hot ends that come on cheaper printers will have a limit to how hot they can get safely. That becomes an issue if you want to venture off into different materials beyond common PLA that have higher melting points. And nozzles are the same story. A cheaper stainless steel nozzle is fine for basic plastics, but if you venture off into abrasive materials like carbon fiber or glass fiber or metallics, you will need a hardened steel nozzle. A 0.4 millimeter nozzle is your most common basic nozzle, and that's what you want to start with. It's the perfect Goldilocks size. It's not too big and it's not too small. Now, if you want a finer detail in your print, you can go down in size to 0.2, but it will slow down your print. And if you want a faster print, you can go up to 0.6. But you'll lose a little bit of quality if you have fine detail. I use 0.4 in all my printers, so don't overthink it. That's the one you want to start with. This is a magnetic PEI adhesion bed. Some people use glass beds because they're animals, but I prefer either a smooth or textured PEI magnetic bed that is flexible. For this reason right here. I'd recommend getting a textured bed to start with. Now this 3D printed part started as a 3D model, and to get that out of the matrix and into real life, it was sliced into hundreds of layers a fraction of a millimeter tall. The free software that slices the model is called a slicer, naturally, and the slicer is where a lot of the magic happens. Coming up, I'll show you some crucial settings and tweaks to know in your slicer that'll take your prints to the professional looking level while saving you from wasting filament and wasting money. And one last thing. You're probably wondering how much electricity one of these printers uses and if it's expensive to run. Now you can get one of these magic devices to plug into your printer and it will tell you the price of electricity that it's using, which is cool. But let me save you the money on this device by showing you this equation. The average 3D printer uses 100 watts or 0.1 kilowatt hours. The cost of energy depends on where you live, but where I live, it's usually around 10 cents per kilowatt hour. So if you take 10 cents times 0.1 kilowatt hour for every hour a print runs, that comes out to 1 penny per hour of 3D printing. So in theory, you could run a printer for 8 hours a day, 5 days a week for a month, and you would theoretically spend $1.60 in electricity that month for that printer. In other words, don't waste your money on one of these little electricity devices and stop thinking about the cost of electricity for your 3D printer. Your average coffee maker uses more electricity. Now that you understand what a 3D printer does, you're probably wondering which one should you buy or not buy. This is the Creality Ender 3V2, and it was the first printer that I bought. It cost me around $350 once I replaced all the weak components of it that fail almost immediately when you use it. This is one of the most common printers, and you can find this style all over Snapface used for probably $100. At one point, my print farm had 12 of these, but I sold them all because they're slow and, more crucially, unreliable if you're stressing them and printing a lot in a print farm. Now, some people love these printers, but most beginners hate them. They're really fussy. What you save in money, you will pay 100 times over in frustration and wasted plastic. And if you're a beginner, I suggest you pass on this model. There's a reason why they're for sale on Craigslist. This is the Prusa Mini Plus. I think I paid around $450 for it. Just don't. It costs more than the Enders, has a smaller print bed, and the same print quality. I thought it was a waste of money. This is the Prusa i3 Mark III. I bought 2 of them and paid $800 each because everyone told me they were so much better than the Ender. Here's a hot take. I don't love them. Now, one of these is printed by an Ender and one of them by a Prusa. Can you tell the difference? No. Now, I was able to get my cheap Enders to look as good as the Prusas for a lot less. Now, here's the good. We owe a lot to Prusa. They helped pioneer this whole thing, and the Prusas are way more stable and reliable than Enders for sure. This printer is basically a Toyota Jeep, solid, reliable, and easy to fix when it breaks down. But the problem is, they're pretty slow, and Prusa seems to be falling behind in technology. My friend Travis recently said, Prusa has become the BlackBerry of 3D printers, which is kind of funny. Now, if this printer costs $400, I'd say it's a good deal, but the new Mark IV version, which is a big improvement, is still $1,100 plus shipping and import duties. And for that price, you can get something better, and you should. Now it's time to talk about the 5,000-pound panda in the room. When Bamboo first came onto the scene, I was very skeptical because a lot of 3D printing companies from overseas have made a big splash, promised crazy tech, took everyone's money, and then they basically disappear. And I expected Bamboo to do that. So despite not loving my 12 Enders, I stayed with them despite the hype of the Bamboo P1P. Bamboo sent shockwaves into the 3D printing community with this machine. This is how slow the Enders print. And this is the P1P. It's certified nuts. And you can get one of these for about $500 now, which is $100 more than I paid for with my upgraded Enders. But I don't think you should buy this printer. But for a woodworker, I think you want an enclosed chamber, mainly to keep sawdust out, but also to regulate the temperature around the print to control the cooling. So if Prusa is the BlackBerry, you want to buy the Apple-looking 3D printer, the flagship X1C from Bamboo, right? Not so fast. It's $1,200. And it prints the same speed as the $500 P1P, but has an enclosure, touchscreen, some cameras to detect print failures, and an upgraded nozzle and extruder gear for abrasive filaments. So many people buy this printer, and I get it. It's nice. I love mine. It's beautiful. I haven't found anything wrong with it. It's basically a perfect 3D printer. It's just that if you're getting into this, I think there's another option that often goes unnoticed, and that's the one that I went with. It's time we talk about the middle child, the P1S. It's the middle of Bamboo's top tier line, and I think it's the best value 3D printer. This is the exact printer that I replaced my 12 Enders with. I paid for 10 of these printers, and I love them. I use them every day for my business. Now, if you compare the P1P, the P1S, and the X1C, you will get the same print speeds and print quality from each one. And the P1S is half the price of the X. Now, the print bed is the same size, and it's big enough to do everything you're going to want to do. Plus, there's no manual calibration needed with these printers. There's also very little setup. I usually start printing about 15 minutes out of the box. Now, is a touchscreen and a camera that detects a bad first layer worth $600? Well, that's for you to decide. But for me, I'd rather go with the best value, and that's the P1S. Now, I hate the interface on the P1S, but instead of paying $600 to get a touchscreen, I use the touchscreen I already have and use my phone to control the printer. Now, there's some tricks I'll show you in the slicer chapter that are free, and it'll help you get a perfect first layer 99% of the time, so you don't need to depend on special software in the X1C. Now, if the cost of the P1S is too much for you, you can save a couple $100 and get the A1, which is Bamboo's open frame printer that's in the shape of the Ender and the Prusa. Now, I don't have an A1, so take all of this with a grain of salt, but I know a few people who have them and love them. They seem to work fine for a hobbyist, but I would not recommend them for a print farm. I will reiterate, for a workshop environment, I think an enclosed printer like the P1S is going to end up serving you much better over time than an open frame printer. If you're familiar with the Bamboo printers, then you've probably seen this accessory sitting on top of a lot of them. It's called the AMS. Now, I'm conflicted with the AMS, and my thoughts are somewhat nuanced here, so go with me. My first impressions were that I didn't like it. It felt very version 1.0 to me. It's not terrible, it's just that the Bamboo printers are so well designed and made, they don't feel like junk, that the AMS, being all plastic, kind of feels cheap. And coming in hot at $350, I think it's overpriced. Now, if it were $99 or $199, I think it'd be a good value. That said, there's a lot of reasons you might want an AMS. With one AMS, you can do 4 color prints. You can link a max of 4 of them together and achieve 16 color prints, which is crazy. Now, one downside to printing with a single spool is if you run out mid-print, it'll interrupt your print. And if you're away from the printer or you're sleeping, that can be a huge issue. But with the AMS, there's a seamless transition to backup with a new spool. You'll get uninterrupted printing and it minimizes waste and failed prints. You can also do multi-material prints and use special support filament that breaks away easier or even dissolves. And the AMS has an airtight seal, uses desiccant material to absorb moisture, keeping your filament dry, which is super important. A built-in humidity sensor monitors the moisture levels inside the AMS, alerting you if humidity rises or if the desiccant needs to be replaced, which is kind of smart. Now, those are all cool and useful features, but my favorite feature is when you use Bamboo filaments. Their filaments have hidden RFID tags on the inside, and the AMS can read which filament you just loaded, and it automatically loads the profiles, brings up the right default settings, and it's super easy. For those of us who are used to loading and building our own filament profiles the old way, this feels like cheating, and it's pretty cool. Now, if you want to do multicolor prints or have multiple filaments ready to go at a moment's notice, then this is a must. Other than that, I don't use it as much as I thought I would. It's a luxury, and I think it should be priced lower. In order to 3D print, you need a 3D model. And if you don't know how to 3D model anything, you'll be pleased to know that it's pretty easy to find 3D files for almost anything you need, usually for free. Now, if you want more specialized and higher quality designs, there are many designers out there who sell specific solutions very affordably. And I'm more than happy to pay someone the equivalent of a cup of coffee in exchange for their intellectual property and design time that I couldn't do. This is called Thingiverse, and it's free once you wade through all the ads. It's decent. I give it a solid B-, sometimes a C+, depending on the type of day that the server is having. There's a lot of junk on there because anyone can upload to it, but there's also some really good finds. Then there's Printables, which is from Prusa, and generally really good models and designers on there. A+ for sure, and no ads, which is a bonus. MakerWorld is Bamboo's file sharing site, and in the beginning, there was not much on there, so I ignored it. But every day, there are more and more models being uploaded to MakerWorld. Now, one thing that sets them apart is you can find a file on your phone and directly send it to your printer without opening a slicer on your computer. So handy, which is actually the name of the phone app, Handy. There's a few other sites like Things, but Printables, MakerWorld, and Thingiverse are the ones that I mainly use in that order. The files you download are called STLs usually, and any STL will work with any 3D printer, so you're not locked in. Now, 2 special things to note here. 1, remixes are really cool. Usually someone will start with an idea and then other people can remix that design and make tweaks or upgrades, and then they post that for you to download. It's really cool to see a community of makers collectively making things better together for free. Now, 2nd, pay close attention to the commercial license. A lot of people work hard on these files and offer them for free, and depending on their preference, they have the option to restrict files from commercial use, or they can allow it. And there are some bad faith characters out there who download these, even if the license bans from commercial use, and then they go on Etsy or eBay or Snapbase and sell the prints illegally, passing them off as their own designs. Those people are the worst, and they should be forced to binge watch Ben's woodworking. These file sharing sites are incredible, but they're also overwhelming. So to get you started, my design partner Steve and I created a bundle with a bunch of basic woodworking files that we designed that we like and even use in our own shops. They're applicable to almost every woodworker, solve a problem, and they're easy to print, giving you a quick win right out of the gate. They will save you so much time from searching through tens of thousands of models looking for the basic ones that everyone wants. There's a link in the description below to my online store where you can buy the pack and start printing today without searching through a bunch of files. There's also a bonus file in there that we just designed that will give you a nice laugh if you've been watching the channel for any amount of time. Now in a moment, I will walk you through 25 more of my favorite files that you can find for free that are specific to woodworking. But what if you want to make your own files? If you've never modeled anything, check out Tinkercad. That's where I got started. It's like the program Microsoft Paint, pretty basic, but it'll get simple jobs done without overwhelming you with tons of tools. Feel free to judge me, but I still use Tinkercad today. Here's an example of how simple it is. I'm making a scale model of my new workshop that I'm building, and I want to get an idea of how to lay out all my tools. Travis from Shop Nation did this a while back, and I got a lot of files from him on things for free. But there were some specific tools that I still needed. I wanted to see how this bench would look in the new space, so we modeled up a basic version in Tinkercad, and about 30 minutes later, I had a one-of-a-kind 1/24th scale Craig bench for my maker dollhouse. Now, Tinkercad has its obvious limitations, and if you want to get more serious and use the Photoshop equivalent, check out Fusion. It can be overwhelming for a beginner. Bob from I Like to Make Stuff has a Fusion course specifically tailored to makers if you want to get straight to it and learn what you need to learn to make woodworking projects. I bought it last year and it's fantastic. Of course, there's loads of YouTube channels dedicated to teaching Fusion or even SketchUp. One channel I've learned a lot from is Product Design Online. This is the internet. It's amazing what you can learn for free now. Thank you, Al Gore.
So I took the initiative in creating the internet.
If opening a slicer is intimidating, I totally understand. The first time that I went to print something, I was really intimidated and didn't know where to start, and I'm a computer guy. I'll show you just how easy it is, and there's some slick tricks that I use on every print that I do commercially and for myself. Remember when I talked about how one of the features of the X1C printer is that it inspects the first layer and also monitors for spaghetti failure? Those are truly amazing features, but I don't depend on those, which is why I bought the P1S. And the reason I can get away with that is with these tricks in the slicer. But what I'm about to show you took me so many videos on YouTube to find. I don't remember where I found it, but it's not original to me, but it works every time. To get a strong foundation for any 3D print, you want the strongest adhesion possible, and that starts with getting the best first layer on your 3D print. Here's what I do. I first go to my temperature settings for my bed, and on the first layer, I set it to be about 5 degrees hotter than usual. So my first layer is usually 65 degrees Celsius, and then the rest of the print, it goes down to 60. Then I go to my nozzle. I set that first layer to be about 5 degrees hotter than usual. So usually for PLA, I'll print at 220. So for my first layer, I set it to 225. Then I go to my layer height. I usually print at 0.2 millimeters layer height. So for the first layer, I bump that up to 0.28. Then I go to the nozzle width. Now, depending on your nozzle width, you can go up to 150% more for your width. So I usually set my first layer width to be 0.55 or 0.6 when I'm using a 0.4 nozzle. I then go to my first layer speeds and I slow that thing down all the way to 30 millimeters per second, which is really slow. Now, all of these settings combined for your first layer are going to give you a solid base layer that is a little bit thicker and a little bit taller and a little bit hotter than normal, giving you the best chance for success because you want a nice fat squish. Now, before we hit print, we're going to make sure our print bed is clean. I try my best not to touch the print bed because the oils on our hands can get on the surface and make it impossible to stick to. To clean your bed, just wash it in warm soapy water at the sink. Dry it, and then spray 91% IPA on it, wipe it off, and you're good to go. One pro tip here, never spray the IPA on a hot print bed. It will just evaporate immediately, and it'll reduce the adhesion of the bed. Now, if you want to take this a step further, which is what I do, go raid your kid's backpack and steal an Elmer's glue stick. There are really expensive special 3D printing glue sticks on the market. Hard note, just pass on it. Use the cheapest Elmer's, it's okay. This will help the plastic stick a little bit more, but it will also give a buffer layer so you won't have too much adhesion and fuse the parts to the bed, which can happen with filaments like PETG and others. I can't overstate how important this first layer trick is. You could spend an extra $600 to get an X1C that has spaghetti detection, and that'll check for a good first layer, and that technology is amazing. But I just use these settings and I get a perfect print every time because of that first layer. Now, a common problem that you'll run into is stringing. Stringing is super frustrating because there can be a lot of different causes, and sometimes it's hard to pinpoint which one it is. Stringing can be caused by moisture in the filament, the specific hardware that you're using, slicer settings, the geometry of your design, or a combination of all of those, which is frustrating. I once had a stringing issue that developed randomly one day on a printer and a part that had printed perfect 1,000 times before. After going through all of the checklists and watching 200 videos on YouTube trying to figure out stringing, I changed the nozzle to a fresh one and perfect prints returned. Now, I used to get clogs all the time with my enders, but with my bamboo printers, I hardly ever get a clog unless I'm using carbon fiber. That said, clogs happen for a variety of reasons, usually because the nozzle temp is too low or there's old filament remnants in there that are stuck clogging things up. Sometimes I'll get a filament and it'll say to print at, say, 200C. But if I hear clicking in the extruder and it clogs or under extrudes, that's a clue that the filament isn't soft enough. And so I'll raise my temperature up in 5-degree increments until I get a good flow. Now, if you see prints that start to look like this, then you probably have a clog slowly developing. This is called under extrusion. And when you get a clog, and you will, there are 2 ways to go about cleaning them. The first is by throwing the printer out. I'm kidding, you don't need to do that. You can use a thin needle to unclog the nozzle once the nozzle is hot, and it usually works for me. These usually come with your printer. But every now and then, you might have a serious clog and the thread the needle trick doesn't work. If that's the case, a cold pull is your best friend. Cool your nozzle down to 0 degrees, and then you heat it back up. And around 120 degrees C, you start pulling on the filament. Now, it won't come out because it hasn't softened yet and is still fused to the nozzle. But as it approaches its melting point, you'll reach a point where you'll suddenly be able to pull it out. And when it comes out, it'll grab anything that is clogging the nozzle. Now, I like to do this with a white PLA filament so I can see the gunk that it's removing and the shape of the nozzle, which is kind of cool. And I usually do this 2 to 3 times for good measure, and then I'm good to go. Now, if you keep getting clogs, consider upping the nozzle size. I fell in love with a PETG CF recently, but despite all my best attempts, the 0.4 nozzle would clog about 1 in every 10 prints. So I changed to a 0.6 nozzle and it printed perfectly, and faster, and stronger. Here's everything else you need to know about slicing in under 90 seconds. To get a file into the slicer, just drag it in. And if you want to change how the file is facing down, you can hit this auto button or manually select the face using this tool. To scale a file up or down, you do that here. And this is a common thing you'll do when fine-tuning parts that need to fit snug, like a dog hole cover. You can duplicate your file by right-clicking on it or by copy and pasting with the keyboard. You can also click Fill Bed with Copies and get this, which is cool. If you're printing something for the first time to test it, you can save print time and material by reducing the walls and also by reducing the infill. For normal prints, I usually do 3 to 4 walls and 20% infill. Start there. If you're having problems with the print sticking while printing, you can add a raft and it will snap off easily after you're done. Sometimes you'll need to add supports. Click this button and it will add them automatically. Tree supports are my favorite. You can also cut a file. This is a scribing block that's in our special STL pack. It uses a utility knife and is really useful when scribing trim. If you want a 1/2-inch scribe block, note this number right here, go into the cut settings, input it, perform the cut, and delete the rest. There you go. Congratulations, you now know enough to start printing, and we only wasted 90 seconds of your time. You're welcome. I'm sure in your woodworking journey, you've come across problems that really bothered you, and those are prime opportunities to come up with a solution that other people would probably pay you for. And there's no better place to sell those solutions than the sponsor of today's video, Shopify. That's exactly what I did with track saws. There are some things about track saws that bothered me, like this hole in the side, or the sharp ends of a track. So I made some solutions with 3D printing. And then I offered them to the world with Shopify. And that's when things got really crazy. We just did the same thing with trim routers. We made this oversized base and custom designed this dust chute to collect most of the sawdust when routing. We just released these and have shipped over 645 around the world already. Now when people ask, how do you buy all these track saws or trim routers or 3D printers? The answer is legitimately Shopify. Now, I didn't go to business school and I don't know how to code. It still blows my mind that someone like me can run a business that ships around the world using my smartphone. They've really figured out how to take all the complexity out of running an online business. There's no need to code. They have a simple drag and drop store editor, which helps me easily make changes to my storefront anytime I want. They have this live view tool that is awesome. It shows you in real time where people are viewing your store. The marketing tools are easy to use, and the back office dashboards and analytics help me oversee all of my operations. It's easy to track my orders, manage inventory, issue discounts, and create new product listings. Now, if you have a business idea or you already own a business, go to shopify.com/WOODWORKERS to get started so you can build the life you want. Similar to woodworking, you want your material to be as dry as possible. Just as excessive moisture in wood can ruin a project, too much moisture in filament can lead to problems like clogged nozzles, under extrusion, and weak parts. I learned this lesson the hard way and wasted a lot of money on cheap filament. If you buy low quality filament, you're almost always going to regret it. Those manufacturers skimp on the drying process to maximize profits and keep costs low. That's why it's cheap. The result is you're going to have problems printing because there's too much moisture content. It's like making a table out of 2x6s with 20% moisture content versus properly milled rift-sawn white oak. The outcome and the joy you get in the process of making it is going to be completely dependent on the quality of the source material and how dry it is. Now, in the beginning of my journey, this was a big frustration for me. One day I gave in and bought some Filament for $38 a roll, and I was blown away with how perfect it printed. No stringing, no under extrusion, no clogs. Some prints would look so perfect they almost seemed injection molded. Your takeaway here is, with filament, you often get what you pay for. I wasted a lot of money on filament from Amazon companies that I can't pronounce their name. They seem to be hit or miss, mostly miss. For my commercial prints, I use a company called Protopasta, but their rolls are $50 a roll. I buy in bulk and get a discount, but it still comes out to about $38 a roll. And that's probably way too much for you, and I would agree with that. Recently, I tried a bunch of different options from Bamboo, and I had very low expectations. Now, I want to reiterate, I'm not sponsored by them and they didn't pay me to make this video, but I've been testing their filaments for the past 7 months, and I've decided to start transitioning some of my commercial prints to some of their stronger filament options because it's better and cheaper. When you consider the RFID tag, the affordable cost, the wide range of strength and use case options, the great quality, and the ease of prints, it's kind of hard to not like them, and it really feels like cheating, and I'm a customer. If you're just starting out and you have a Bamboo printer, don't waste time on Amazon or any of those other companies. Just drink the Panda Kool-Aid and get their filament. It's usually the same price as what you'd find on Amazon anyway, plus they're made to work with their machines. Quality filament from the start is only half of the problem. The other half is on you keeping the filament dry. That's because 3D printing materials are hygroscopic, which is a $15 word that basically means it absorbs moisture from the air. So it's necessary to both dry the filament when making it and maintain this dryness, which can be a challenge if there's high humidity in your environment. A lot of people store their filament on a wall and out in the open. It looks cool, it's certainly convenient, but I don't do that. I'm probably paranoid, but I store all of my filament in a waterproof storage tote that has a rubber gasket seal on the lid. I throw the desiccants that come with the filament in there to absorb any moisture, and it works. I've had some of these rolls for 3 years, and they're still printing perfectly when I call on them. And when you open filament, if it comes in a resealable bag, keep that and store the filament in it with a desiccant when you're not using it. Filament types is a whole rabbit hole, so here's the distilled breakdown of what you need to know to get started. PLA is your most common and basic filament type. It's what you want to start with, and it's good for basic prints, especially if they're not going to be subjected to extreme temperatures or mechanical stress. The cool thing about PLA is it's a natural polymer derived from renewable resources such as cornstarch or sugarcane. It's intended to replace commonly used petroleum-based plastics like PET, and it's definitely what you want to start with. You can get PLA in pretty much every color, including some cool multicolor options, metallic and marble. The pros is cheap and easy to print. If you can't print PLA, I'm sorry, this hobby is not in the cards for you. The cons, it melts easily in hot environments and is brittle. It's not very strong. So if you want to 3D print tool holders that will live in your garage, PLA is risky depending on how heavy the tool is. There's other filaments for that. PETG is one of those, and it's the next step up. It's stronger, more durable, and more impact resistant. It has a little bit of flex in it. PETG also resists chemicals and water better and can withstand higher temperatures, which is why I like it. Now, after you successfully print with PLA, PETG is your next milestone. The pros, higher melting temp and has a slight flex to it, making it less brittle. The cons, because of the higher melting point, you need a hot end that can safely reach those temperatures, which cheaper printers usually don't have. PETG also has the ability to stick too much to your build plate, which can ruin your build plate. Glue stick is your friend here. I always use glue stick on the print bed when using PETG. ABS is probably something you're more familiar with as it's often been used in commercial plastic products. It's got some toxic fumes and is a pain to print due to its warping. But I just discovered a new version of ABS that I was able to print perfect the first time. Shocker, it's from bamboo and it has glass fibers in it, hence the GF here. It's about 30 bucks a roll, which is a deal for the quality of this stuff. I've begun transitioning all of my commercial 3D prints from PETG to this ABS GF. It's cheaper than my current PETG supplier and is stronger, so it's a win-win. It's my new favorite filament. The pros, it's durable and has a high impact resistance. The cons, it can be tricky to print due to warping and the fumes are concerning, so make sure you print in a well-ventilated area. ASA is a modified version of ABS with added acrylate, making it more weather resistant and better at handling UV exposure. Now, I've not done this, but this is pretty cool. I've seen examples of people printing outdoor birdhouses and even drone parts with ASA. The pros, crazy UV and temperature resistance and high impact strength and durability. Cons, it tends to warp due to temperature differences between the model and its surroundings. ASA also emits potentially harmful fumes during printing, so like ABS, it's important to use it in a well-ventilated area. PA6 is one of the most extensively used plastics globally. A lot of your car parts and tool parts in your shop are injection molded using PA6. The pros, superior strength and stiffness with exceptional thermal resistance. Cons, it's highly sensitive to humidity and usually needs to be dried in a dryer before use. And it's on the more expensive range of filaments at around $43 a spool. Now, speaking of temperature resistance, we took a blowtorch to one and it did not want to stay on fire. Now, TPU is a type of plastic that's a combination of rubber and plastic with properties of both. That means it's both flexible and durable. The floor mats in your car as well as your phone case are most likely a form of TPU. The pros, it's flexible and more rubbery. The cons, it can be really challenging to print without stringing or cosmetic problems. I haven't mastered it yet. It needs to be printed slower and is more on the expensive range of filaments at 41 bucks a spool depending on the quality. It does not like fire. It basically melted like a marshmallow. Unfortunately, not everything you need comes with your 3D printer. Now here are 10 small tools that I find myself using all the time. A flush trimmer, 100% non-negotiable. Use this tool to cut filament at a 45-degree angle so that it will feed better into your printer. I also use this to flush cut any extra material. Digital calipers. You might already have these already, but it's helpful to have in designing and also double checking to make sure that your printer is accurately reproducing what's in the slicer. A brass brush. I have a cheap one from Harbor Freight that I use occasionally to clean nozzles, and it's awesome. Your printer probably came with a thin needle. Do not throw this away. You will need this for clogs. A Dremel is nice to have for cleanup tasks and for sanding parts. Sometimes I'll use a putty knife or a spatula to get prints off the print bed. Elmer's glue. Don't buy expensive 3D printing glue. Just raid your kid's backpack. 91% IPA. In case you don't know, the higher the percentage, the faster it evaporates, which is great to have with electronics. Don't spray it on the bed when it's hot. A heat press. Eventually, you might want to set threads into 3D printing parts, and this heat press does that and it's super cool. A dryer. If you have wet filament, you can put it in a dryer and it will take the moisture out of your plastic. This is a must to have. Now this is my favorite part of the video because the creativity out there is unreal. I'm gonna go through these rapid fire, but I'll link to all of these in the description below. These are prints that you wanna save and print at some point. One of the first things you should print are cordless battery holders for whatever drill you have. Go to Thingiverse, type in DeWalt. This is my favorite DeWalt battery that I've printed. This one is for Makita, and out of all the designs, this one's my personal favorite. Easy to print, and I have printed maybe 10 of these. I plan on printing these Milwaukee ones soon. I'm a Makita man and a Festool fanboy, but this is for all my Ryobi people. Go to Thingiverse or Printables and type in Ryobi 18V. You're welcome. Just remember, if you print these to hang heavy tools, use PETG. PLA will not be strong enough in a garage that gets hot. It will fail. Your tool will fall on the ground and almost hit your wife's car. Ask me how I know. I know a lot of people have Ego batteries for their yard gear, and this is the best Ego battery holder that I found. I love this thing. Slim, easy to print. The very first thing I printed 3 years ago was a miter saw bar. I kind of hate making hardwood runners for my table saw, and I don't like paying a lot of money for the aluminum metal ones, so I just print these. Use them for all my sleds and jigs. Super easy and satisfying to make. Regardless of the sander you have, there's probably a file that will hold your sander to the wall. Even if you have a 3x4 surf prep, here's a great file for that. I also printed this one for my Festool sander. If you have these ratchet style clamps, there's so many options for you to store them, and this is the one that I use. Also, I love the stop block that keeps it from collapsing when using it on an MFT table. I'm about to blow your mind. The number one reason you should get a 3D printer is this: vacuum hose adapters. 707 of them. Pretty much any connection you will ever need for dust collection is right here for free. If you want to do something cool like a flat hose tunnel, this is a cool file. If you've ever needed to use setup blocks or shims and you just don't want to use the playing card trick, here you go. Now for you hand tool purists, if you've lost your chisel sheath, someone made a replacement that you can print. I mean, it doesn't get more obscure and niche than that. You can even print chisel holders and a chisel plane. Kind of cool. If you need a quick and disposable paint or epoxy mixer, some really cool designs. If your Starbond superglue is out of control, here's your answer. If you have a JESSM router lift, here's some custom inserts. This self-centering drill guide is actually pretty brilliant. Have you ever run out of drywall anchors, needed one, and needed to run to the store just to buy one or two and ended up with a whole box? Home Depot is going to hate the designer of this model. If your batteries are out of control, this is awesome. I actually have one of these in my kitchen. I'm pretty sure no matter what bandsaw you have, there is a zero clearance insert made for that. Just search bandsaw on printables.com. Since John Malecki is really busy ripping off TikToks, I found this one so that he can print one for his Shopsmith bandsaw. For you SawStop owners, if you've ever been cutting wood and wish you had a secret utility drawer in your fence to store your hot dogs, Ben Myers is here to serve you. If you make a lot of jigs and you need handles and you don't want to buy them, then you can handle this. Wouldn't it be great if F-style clamps had stands? Now they do, for free. I love these Milwaukee speed squares. I have both sizes, and I'm so glad that someone made this holder for them. Every domino user has tried to dry fit a project and then struggled to get the very tight tenons out so they can glue them up. Now you can 3D print reduced size dominoes for dry fits. You can also print a custom domino sized glue nozzle for type-on bottles. And this is my favorite. You can print an insert that will organize all of your bits and wrench inside a cute little micro sustainer. Speaking of Festool, the brand has released some free STLs, and I wish more brands would do this. It's kind of cool. If you're a Match Fit fan, you can print your own fixture bits and knobs. For those of us with trucks and ratchet straps, this is the answer we've all been looking for. Now, there are some of you who think I've committed the greatest sin against the 3D printing community for leaving out, quite possibly, the greatest invention of all time. But no, I did not forget. I was saving the best for last. So, take a deep breath and back away from your Cheeto-stained keyboard because I'm about to say the one word you've been dying to hear this entire video. Gridfinity. Imagine the most comprehensive and flexible storage system created by a cyborg who is more sarcastic than me. Well, you don't have to imagine it, because that's exactly what Gridfinity is.